Okay, so to start off this unit on geometry, we're going to be dealing with a lot of properties of lines and line segments and circles and all these other different shapes. So we're starting off with this whole idea of midpoint. So the midpoint would be the point that's halfway between two other points, two endpoints in a line segment. So let's say we have a line segment that starts at -4, 2 and ends at 6, 8. We want to find the points at the same distance from either end, halfway across. So think about how you might find it, and let's just start by using your intuition here. So if you were to count here, you'll see that we go up from start to finish. So if you look at the y values, we go up from 2 to 8, so we go up 6. And if you look at the x values here, we go from -4 to 6, we go over 10. So we go across 10 and up 6. Well, what if we cut that in half? What if we go half the distance along the x and half the distance along the y? So that would mean we'd be going 5 along the x and 3 along the y. That would put us right here. And that, lo and behold, is our midpoint. Okay, so if we want to see the coordinates of that point, it's going to be at the coordinates 1 and 5. So can you think about a potentially calculation type way we might be able to go get that? So because right now we could be able to see that midpoint just by sketching on a graph, but how do we actually calculate it? Well, you might notice that the x value 1 is halfway between -4 and 6. The y value is 5 is halfway between 2 and 8. So if we find out the x value is halfway between our endpoints and the y value is halfway between our endpoints, we can get our midpoint. So what we have now is a formula for the midpoint where we take our two x values, add them together, divide by 2, take our two y values, add them together, divide by 2. So in our case, for example, here, our midpoint would be, our x values are -4 and 6. We have -4 plus 6 divided by 2. And then for the y value, 2 plus 8 divided by 2. So I simplify each of those, and our midpoint is going to be -4 plus 6 is 2, divided by 2 is 1. 2 plus 8 is 10, divided by 2 is 5. So there's a nice quick way to calculate the midpoint. And thankfully it's nice when the math kind of suits our intuition. Your first guess might have been to find the value that's halfway across for x and y, and it does work for the midpoint. Okay, so let's try and do a bit of practice. So the endpoints of a diameter of the circle are at 16.3 and -25 and 8.2, 10. We will want to find the coordinates of the center of the circle. So let's picture what this is going to look like here. So I'm going to take a circle. There it is. And somewhere I'm going to have a diameter on there. So diameter, remember, is a line going across the circle that passes through the center. So I'm going to put my center somewhere around here. So the endpoints of this diameter we're saying are 16.3, -25. Okay, so that was point P. And the point Q is going to be at 8.2, 10. Now you can see this obviously isn't really on the scale. It's not really in Cartesian planes. These points don't really make sense with each other. But the idea is still the same. What we're trying to find, if these are the two endpoints, we're trying to find the center, which will be halfway between these 2 points. So to find our midpoint, we're going to take our two x values and divide them by, add them together, divide by 2. So I'm going to get 8.2 plus 16.3. I'm going to divide that by 2. And then for my y values, do the same thing. So I'll have 10 plus -25, all divided by 2. So run each of those through my calculator. 8.2 plus 16.3 is 24.5. And 10 plus -25 is -15. So I'll have -15 divided by 2. Okay, so again, leave them as fractions, leave them as decimals. If they are going to be fractions, simplify as much as you can. But let's do this one in decimals. 24.5 divided by 2 is 12.25. And negative 15 over 2 is negative 7.5. Okay, so these would be the coordinates of the center. It's the midpoint halfway between the two endpoints of the diameter. Okay, let's keep going. So here I'm telling you one endpoint of a line segment is negative 2, 7, and the midpoint is 5, negative 3. Now I want to find the coordinates of the other endpoint. So a quick little sketch might help here. So 5, negative 3 is going to be somewhere down here. And that's going to be the midpoint right now. Okay, negative 2, 7 is going to be somewhere up here. And that's the endpoint that we're just going to call, let's just call it A for now. So essentially what's happening is, if m's the midpoint, then this line continues on again for the same distance it already has continued on. And we need to find this other point B. So I want you to think about how you could find this other point. There's a couple ways I can think of. So try and figure out the other point. When you're ready to see the answer, push play and we'll run through it together. Okay, so the other endpoint of this line segment is going to be at 12, negative 13. Now how do we go about doing it? So one way you can do it is from the sketch actually just counting out the amount you've gone from the endpoint to one midpoint, then continuing on by that same amount to find the other endpoint. So what I mean is, if you're taking a look here, going from A to the midpoint, sorry, A to the midpoint there, so my y value went from 7 to negative 3, so I've gone down 10. My x value has gone from negative 2 to 5, so negative 2 to 5 is going up 7. If I go again by that same amount for x and y, I should get my new point, because again the midpoint's halfway between A and B. So if I go down another 10 and over another 7, how does that change my coordinates? So for my x value, it's at 5 from the midpoint. If it adds 7, 5 plus 7 gives me 12. If my y value is negative 3, subtract 10 from that, I get negative 13. And that was my other endpoint. Okay, the other thing you can do, if you don't like doing it this way, and if you're the kind of person who likes doing algebra, we can actually do this with the midpoint formula. So, knowing that my midpoint formula is x1 plus x2 over 2, and y1 plus y2 over 2, I can set up a separate equation for both my x and y values. So basically, these x1s and x2s come from my two endpoints. So my first endpoint has an x value of negative 2. So if I take negative 2 plus whatever my second x value is, I'll call it x2, and divide it by 2, I know what the x value of my midpoint is. It's going to be 5. So just to recap here, from one endpoint I got an x value of negative 2. I add that to some value that I don't know, and divide it by 2 to give me the middle x value, which is 5. This is an equation I can actually solve for x2. I can create a different equation here for y. So my first y value is 7. So 7 plus some unknown y value from point B divided by 2 gives me a y value for the midpoint of negative 3. So I can solve both of these equations. So for the one on the left, I'm going to multiply both sides of the equation by 2 first. So I get negative 2 plus x2. 5 times 2 gives me 10. So once I add 2 to both sides of the equation, I get x2 being 12. If I do the same thing over here, multiply both sides of the equation by 2, I get 7 plus y2 equals negative 6. Subtract 7 from both sides, solve for y2, I get y2 equals negative 13. And that 12, negative 13 are the coordinates of my other endpoint. So there's two different approaches there to find that other endpoint. If you either one works, so whichever one you prefer is fine by me. Okay, so let's take a look at a few other things here. I'm going to look at some special kinds of lines in geometry called perpendicular bisectors and medians. So perpendicular bisector, it's a line or line segment. It's perpendicular to a given line segment and passes through its midpoint. So if I have a line segment right here that I've drawn, a perpendicular bisector, the line will pass through the midpoint. Okay, so this point right here would be the midpoint. And it passes through it at a 90-degree angle. Okay, so it bisects, cuts it in half, and at a 90-degree angle. So you might see it called a right bisector sometimes because it's a little bit easier to say than perpendicular bisector. And also we have this idea of a median. Now you may have seen a median in statistics referring to the middle number in a data set. That's not what we're talking about here. In geometry, it's a line or a line segment that goes from a vertex, or i.e. corner of a triangle, to the midpoint of the opposite side. So for example, if I have a triangle here, this line right here would be considered a median. So it goes from one of the endpoints or vertexes of the triangle, and it goes through the midpoint of the side across the triangle from it. Okay, so that would be a median. Okay, so what we're going to do now is actually try and find an equation of the right bisector. Now remember, the right bisector is a line, so it does have a specific form. Remember equation of a line from grade 9, we've seen a few different forms. You saw a standard form, you saw a point slope form, you saw a slope intercept form. So remember that the right bisector is a line. So if you're going to use point slope form, it's going to look like y equals m x minus x1 plus y1. Okay, where m is your slope, x1, y1 is at any point anywhere on the line. If you're going to use slope intercept form, it's got to be y equals mx plus b. Okay, I'm going to recommend you use whatever's faster, which most of the time will be point slope form. So again, let's go about doing this one. So if it's going to be a right bisector, we know two things. We know it's going to be perpendicular to this line segment that's given. We know it's going to pass through the midpoint. So let's first try and find the midpoint between the midpoint of this line segment, because that's going to be a point that we know that the right bisector is going to pass through. Okay, so our midpoint is going to be halfway between -1 and 3. So -1 plus 3 all over 2, and halfway between 4 and -2. 4 plus -2 all over 2. So that's going to give me a midpoint of 1 and 1. Okay, so I'm just going to put that on the grid here. So 1, 1 is right around here. So our right bisector is going to pass through that line, but it's going to pass through it at a 90-degree angle. Okay, so it's hard to get a 90-degree angle perfect on this graph, so remember this line continues on forever in all directions. But I'm trying to create a 90-degree angle here. So, okay, now remember, I'm trying to find the equation of this line, so I have a point. The main thing that I need for the equation of the line, though, is the slope. Okay, and I'm going to need that no matter what form I choose to use. I need to find the slope of this line that I just drew. Well, how do we do that? Well, we know it's perpendicular to the one that the line segment I already have, and hopefully from getting I remember how slopes of perpendicular lines are related to each other. So let's say I know the slope of this line segment right here. Our slope should be the negative reciprocal of that one because they're perpendicular. So what I'm going to do here is I'm going to find the slope of our existing line segment of PQ. So I'll do that first. Okay, so don't be confused between big M and little m. Big M refers to midpoint, little m refers to slope. So remember from grade 9, slope is y2 minus y1 over x2 minus x1. So if I use my points that are here, I'm going to have -2 minus 4 over 3 minus -1. Okay, so that's going to be -6. 3 minus -1 is 4, so I get -3 over 2 once I reduce that. Now, our slope, the slope of our actual right bisector, is going to be the negative reciprocal of that because they're perpendicular. So what I'm going to get here for my right bisector, so I'll make a little notation here, m perpendicular, is going to be positive 2 over 3. So you take the reciprocal and then change the sign. So now I have my slope, I have my point, I have everything I need to create point slope form. So if I want to follow this form right here, I'm going to have my slope, my point that I know passed through is the midpoint here, so it's 1, 1. So I'm going to have x minus 1 plus 1. Okay, and I'm done. Okay, this is probably the fastest way to go about doing this one because I have a point, I don't have the y-intercept. We'll look at slope-intercept form in part 2.